So we're asked to find the integral of this function, and we're going to use integration by parts to accomplish this. But first, let's just derive what the integration by parts formula tells us. Right? Well, first, what does the formula actually tell us? So it says that the integral, it's too big, the integral of some function f of x times the derivative of some function g of x is f of x times g of x minus the integral of f prime of x g of x. So this actually comes from the product rule of differentiation, right? So what does the product rule say? So if we have, if you want the derivative of some function f of x g of x, that's given by g of x times f prime of x plus f of x times g prime of x, right? So what if you want to get, so if you want the integral of this, so then that would give us f of x g of x equals the integral of g of x f prime of x plus the integral of f of x g prime of x. Okay, so this is just the taking the integral of both sides. Okay, now we're just gonna move this, so we're gonna move this term to the left hand side. So f of x g of x minus the integral of g of x f prime of x equals the integral of f of x g prime of x. Okay, so this is essentially, this is, so this, let's do that. So this is integration by parts, and so is this, right? So, and this is the same thing. Okay, and this is just simply the derivation. So this is the derivation from the chain, the product rule of differentiation. Okay, so now we can now how are we going to apply this to solve this problem? Well, essentially what we're looking for is, we're looking for a problem that's in this form, right? So if you have, so it's where it's some function times the derivative of some other function, right? And does that fit our problem here? So let's take a look, right? We have the multiplication of two functions, okay, and we do have like, these are both derivatives of some function, right? For example, x, so if you derive, say, okay, well, what's the integral of x, right? So the integral of x is x squared over 2, right? So if you derive x squared over 2, so if you did dx x squared over 2, you should get x, right? So this is just half times 2 times x, 2 minus 1, this cancels out, and that gives you x, right? So that's fine. That could be f of x. So g prime of x could be x, where g of x would be this function, right? Similarly, so if you do the integral of sine of x, this is, so what is the antiderivative of sine of x? So that's negative cosine of x, right? So if you do dx of negative cosine of x, you get the derivative of sine is cosine, so this minus, the derivative of cosine is minus sine x, which is sine x, right? So either of these could be our f of x and or g of x, right? But the idea is that essentially we want to pick, so here's what needs to happen. So we need to find, we need to figure out from this something that's, let's just change color. We need to find something that's f of x. So we need to find a f of x, and we need to find a g prime of x. So we need to pick one of these functions to be one of either of these, and then we also need to find, after that we need to find f prime of x and g of x, right? Because we need that. So if we break this down into this form, and we need the integral of this form, we need these components to figure that out, right? So we need an f prime of x and we need a g of x, okay? And we need f of x and a g prime of x. So how do we decompose, which should be f prime of x and which should be which should be f of x and which should be g prime of x? Well, the way to think about this is that we would like a function that we can derive without too much trouble, and we also want a function that we can integrate without too much, without making things too complicated, right? So this is a bit of a trial and error situation, and you get a better handle of it as you practice. Okay, so for this example, I'm just going to say let f of x equals x, right? That means g prime of x is sine of x. So differentiating this is pretty easy, and it actually makes our lives much easier because it just becomes a constant, right? So whatever this whole thing is just multiplying it by a constant, which would make our lives really easy. So let's just, because we can pull constants out of integrals and make our lives easier, right? So let's just derive that, and so that's going to be f prime of x is going to be 1, and the integral of sine of x is not that hard, it's not that complicated either. It's not going to make a messy problem for us. So let's just, the integral of sine of x, so equals the integral of sine of x, which is negative cosine of x, right? So that's not bad. So now we just put these parts into our equation. So what we have is the integral of x sine of x equals f of x, which is x, times g of x, which is negative cosine of x, minus the integral of g of x, which is negative cosine of x, times f prime of x, which is just 1, right? So this is already done, so this is just minus x cosine of x, right? And this is just, you bring this minus out, so this is just plus the integral of cosine of x, which is, so the antiderivative of cosine of x is sine of x, because if you derive sine of x you get cosine of x, right? And that's just gonna be sine of x plus c, right? And that's our answer.